All right, so this is the key to functions worksheet 10. And in all of these, you want to find the inverse. And notice this notation right here, so don't confuse that -1 that you see in each of these cases. Don't confuse that with the idea of taking the reciprocal. That's not what that is. All right, so this notation here means inverse. So that's a different concept. In number one, you'll notice that number one is a finite set of ordered pairs, so you can actually count them: 1, 2, 3, 4. When you look at the rest of these are written in variable expressions here. So when you look at the rest of these, the points, the number of points on the graph is going to be infinite. So here you have a finite set, here you have an infinite set of ordered pairs. So the way we determine the inverse is going to be different with a finite set versus an infinite set. So in a finite set, it's pretty easy. All you do to find the inverse of a finite set of ordered pairs is you just remember this. So when you have inverses, if -3, 5 is on the graph of g of x, then the point that corresponds to it on the inverse is going to be where you interchange these. So it'll be, in other words, it's going to be, let me go ahead and just do this. So g inverse of x then is going to be, so remember, on g of x you have -3, 5. On the inverse you just interchange the coordinates. So it'll be 5, -3. And then 2, 6 on g of x becomes 6, 2 on the inverse. So that's g inverse. 5, -4, 5, -4 becomes -4, 5. So remember, the domain becomes the range. So you see the domain is -3, 2, 5, and 3. And over here, that domain becomes the range, -3, 2, 5, and the last one's going to be -1, 3. All right, so the domain of g of x becomes the range of the inverse, and the range of g of x, 5, 6, -4, -1. So remember, the range of the set of y coordinates becomes the domain. So notice the x coordinates here are the same as the y coordinates here. All right, so we do the others. You're going to notice that in the process of doing 2, 3, and 4, in the process of doing 2, 3, and 4, we're going to interchange the variables. So x becomes y, y becomes x. Okay? All right, so that is number one. Now, when you look at number 2, you have f of x equal x cubed minus 5. Okay, now, so when you graph this, then this is a polynomial function, so the domain is going to be all real numbers. But regardless, when you graph this, there's an infinite set of points, an infinite set of ordered pairs, whereas here you only had 4. Well, here you only had 4. Here you have an infinite set. So the way you're going to do this is this. So you have to do that algebraic procedure. So first thing you're going to do is replace f of x with y. So you got y equal x cubed minus 5. Now, remember what we said. The x becomes y, the y becomes x. So now we're going to interchange the variables. So we have x equal y cubed minus 5. So that's that idea. The domain becomes the range becomes the domain of the inverse. And so once you interchange the variables, then you're going to solve for y. So now we're going to do that process of solving for y. So go from here to here. Remember, we interchange the variables. Or actually, to go, I guess, from here to here. So to go from here to here, we interchange the variables. To go from here to here, all I did was replace f of x with y. And then you just solve for y. All right, so to solve for y, and this is the only term that involves y, to solve for y, I'm going to add 5 to both sides. So I get x plus 5 equal y cubed. And I'm going to go ahead and just transpose the size. So if x plus y plus 5 equal y cubed, then y cubed equals x plus 5. All right, now I got to get y by itself. Right now I'm cubing y. The opposite of cubing is to take the cube root of both sides. And so then the cube and the cube root into each other, so you get y equal. And by the way, knows the only time you put that plus or minus is when you take the even root. So this was taking the square root of both sides, and you put the plus or minus. But that's an odd root, so you don't do that plus or minus. So then you get the cube root of x plus 5, and you solve for y. And so therefore your answer, so the answer then is now you're going to replace y with the inverse notation. So this is f of x. Then what you found here, let me go ahead and just say this. So this is going to be, I'm going to go ahead and rewrite this over. So what you found is that this is now the inverse. That's the inverse. So the inverse, you're going to say f inverse of x is equal to the cube root of x plus 5. Okay? So that's how you do these. So the idea is to replace f of x with y. Then you're going to interchange the variables. Y becomes so x becomes y, y becomes x. So x becomes y, y becomes x. And then you solve for y, and then whatever that y expression is, that's going to be the inverse. Okay, number 3, let me go and just write this out. So f inverse is going to be the cube root of x plus 5. Okay, now, number 3, you have this. You have h of x is equal to 6 divided by x minus 7. All right, so we have this rational function. And then you want to find its inverse. You want to find h inverse. And notice that in 3 and 4, the work was required. All right, so you're going to do the process. So you're going to replace h of x with y. So y equal 6 divided by x minus 7. Then, remember, to go from here to here, we interchange the variables. So then y becomes x becomes y. So we get x equal 6 divided by y minus 7. And then somehow I've got to get y by itself. All right, now here's one way you can think of this. So I'm going to go ahead and rewrite x as x divided by 1 equals 6 divided by y minus 7. And notice that the least common denominator is y minus 7. So at this point, I'm just rewriting this over. At this point, I'm going to go ahead and multiply both sides by the least common denominator to clear those fractions. So that's one of the things you learned in probably the first week of the semester. So I'm going to clear the fractions by multiplying both sides by the least common denominator. And so now I get this. I get this, and you got to be careful here. So this is y minus 7 times x. So that means that x is multiplied by every term here. So it's helpful if you put that in parentheses so you don't mess up. So this becomes x times y minus 7 is equal to, and then these y minus 7s divide out, and that's equal to 6. Then it gets a little bit not that easy, but it's doable. At that point, you notice, well, now it looks even more complicated because I have a y and an x on the same side, and I see a multiplication symbol. Well, that's okay. Here's what you're going to do. Let's get rid of the parentheses. I'm going to get rid of the parentheses by using distributive property. So when I use the distributive property, I get xy, and then x times a negative 7 is a negative 7x equals 6, right? Okay, so not that bad. Now what we're going to do is notice that this is the only term. Remember, I'm trying to solve for y, right? So at this point, we got to solve for y. So then this is the only term that has the variable y. So then I'm going to bring this term over, this one right here. So I'm going to add 7x to both sides. So then I have, and I'm running out of room, so let me go ahead and put that here. So then I have xy equal, x times y equal 7x plus 6. So this right here is 7x plus 6. And now notice I can solve for y and I'm done. Because look, if x times y, so you have x times y, right? And so if I'm trying to solve for y, right now multiplying y by x, the opposite of multiplying by x is to divide by x. So I'm going to divide both sides by x. Like this, the x's divide out, and you get y equal 7x plus 6 divided by x. And that's your inverse. So this is h inverse of x. You're done. So the answer, you're going to say h inverse of x is equal to 7x plus 6 divided by x. All right, so that's the inverse for that. So in number 3, you're going to say h inverse of x is going to be 7x plus 6 divided by x. All right, and then finally number 4, so let's take a look at number 4. So number 4, you have a rational function, but notice this time the difference is that in this rational function there was only one term that involved x, and that was this one right here. Whereas in here you have 2 of them. So it's going to probably be a little bit more work, but the idea, the process is going to be the same. So let's take a look at that one. So this number 4, we have k of x is equal to x plus 1 divided by x minus 3. All right, so I want to find the inverse of this rational function. All right, so first thing you're going to do, step 1, is to replace k of x with y. So I get y equal x plus 1 divided by x minus 3. Then the second thing, remember the next step is to interchange the variables. So meaning y becomes x and x becomes y. So to go from here to the next step, you're going to say x equal y plus 1 divided by y minus 3. And just like we did the last time, I'm going to write x as x divided by 1. So x divided by 1 equal y plus 1 divided by y minus 3. And then we're going to clear those fractions. So the least common denominator, so the LCD is going to be y minus 3. So now what I'm going to do to clear those fractions is I'm going to multiply both sides by that least common denominator. All right, so I'm going to go ahead and rewrite this over. All right, so I'm going to say times y minus 3 times y minus 3. All right, now remember how we did the other one, so you really should put that in parentheses here, because notice that this x is multiplied by every term in here. So that's what you see here when we did the distributive property. So do that here. So put that in parentheses. So now what we have is that this right here becomes x times y minus 3 equal, and then these y minus 3's divide out, and you get y plus 1. So notice I cleared the fractions. All right, now at this point, notice you have y on both sides, right? There's y, you have the variable y on both sides. Whereas in the previous one, when you got to that point, there was only one term involving y, and it was on the left-hand side. Here, there are 2 terms. So first of all, when you distribute, you got to do that first. When you distribute, you get x times y minus 3 times x equal y plus 1. All right. So now notice there are 2 terms involving y's, and they're on different sides. What you have to do at this point is you have to bring all the terms that involve y, the factor y, to one side, everything else to the other. All right. So notice you got to bring this y to this side and this negative 3x to the other side. So let's go ahead and do this one first. So let's go ahead and subtract y from both sides. All right, now be careful here. You have 3 things here. So you have xy minus y minus 3x. So 1, 2, 3. 1, 2, 3. So all I'm doing is combining like terms. So these 3 terms I cannot combine, so that's what I have here. Equal, and then when I combine these, y minus y is 0, and you're left with 1. So that's where I'm at. Then, remember, you want to get y by itself. So let's go ahead and get all the terms involving y by itself. So I got to bring this negative 3x to the other side. So I'm going to add 3x to both sides. And so when I combine like terms, this is 0. So I get xy minus y equal, and this becomes 3x plus 1. Those are not like terms, so don't say that's 4x, because that's not a 1x. 1x plus 3x is 4x, but that's not a 1x. That's a 1. So those are not like terms. So all you can do is just say 3x plus 1. Now, you're at this point where you're thinking, well, how am I going to get y by itself? There's two terms involving y, and this one has the factor x with it, but this one does not. Well, think of factoring. So if you look at these two terms, the GCF is y, meaning I can factor out a y. So this right here, these two terms, when I factor out that y, I get y times x minus 1, right? Y times x is yx, y times a negative 1 is a negative y. So I get that equal 3x plus 1. And then to get y by itself, right now I'm multiplying y by x minus 1. So think about the previous one. I think we were right here. So again, to get y by itself, I'm multiplying y by x. So the opposite is to divide by x. That's what we did here. Same thing here. Right now, I'm multiplying y by x minus 1. Let me go ahead and just rewrite this over. And so the opposite of multiplication is division. So I'm going to divide both sides by x minus 1. And then the x minus 1 is divided out, so you get y equal 3x plus 1 divided by x minus 1. And once you get y by itself, that is your inverse. So that's k inverse of x. Notice the notation, k inverse of x. And so therefore your answer, you're going to say k inverse of x is equal to 3x plus 1 divided by x minus 1. All right, and so that's how you find the inverse of a rational function. Notice the work though. So there's some work you had to do. You couldn't do. It's not very easy to have done this in your head. So doing the work and making sure everything is mathematically correct is important. All right, so I'm going to go ahead and write the answer here. So the answer is k inverse of x is 3x plus 1 divided by x minus 1. All right, so that is the key to the worksheet on inverse functions.